All right. So let's look at some of the problems you're going to see in 7.1, where we start working with rational expressions. And of course, we know what a rational expression is. It's um, it's basically a fraction that has as a numerator a polynomial and as a denominator a polynomial. So we want to simplify these. But the first thing we're going to do is, we want to ask this question: are there any places where this is undefined? Because this is a question that is particular to rational expressions. Any numbers where this is undefined? That's the question. So this is a question that's particular to rational expressions. And basically, here's the problem that we have with rational expressions. We can plug numbers in here, just like we do with any kind of expression, but we can never plug in numbers that make the denominator zero because it's a fraction and you would have a zero in the denominator. So in order to answer this question of whether any numbers where this is undefined, what we have to do is figure out where the bottom equals zero. And that's done most easily by factoring the bottom, the denominator, x minus 2, x minus 1. And you can now see that if x equals 2, then the bottom equals 0, and that is undefined. If x equals 1, then also undefined. So x cannot equal 2, and x cannot equal 1. So those are the places where it is undefined. You just factor the denominator and figure out where it is equal to 0. All right, so the other types of problems you're going to see in this particular section are to simplify these rational expressions. And the thing to remember about these is they're fractions. And when you learn about fractions, you learn about simplifying fractions. And so we know that one of the things we do with fractions is we always want to write it in lowest common terms. Like if you have, say, 5/10, right? You'd never leave it as 5/10. You would always reduce that down, simplify it down to 1/2. They're equal, right? 5/10 is equal to 1/2, but um, they this is a simpler version. 1/2 is a simpler version. So that's the idea when we simplify rational expressions. We want to write them in an equal but simpler expression, and so we're going to do that. So we're going to do the same thing. Anytime we have a rational expression, you want to write it in lowest common terms. And so the process for doing this is it's a two-step process. The first thing you do is factor. Okay? So again, you've got to be good at factoring, but you always want to factor first. And then the second thing you do is cancel. All right, so let me demonstrate those pieces with this particular problem right here. All right, so what we're going to do is we factor the numerator and the denominator. You factor the top and the bottom. So the top is a difference of squares, so it's going to be x plus 3, x minus 3. And the bottom is just a good old quadratic, so it looks like x plus 3 and x minus 2 is going to work. So there it is, factored. All right. Now what you do is you get a cancel, and this is the same thing that applies to regular fractions. If you have a factor that is on the top and on the bottom, you get to cancel it. And so look, I've got an x plus 3 and an x plus 3. And so I get to cancel those completely, and so I'm left with x minus 3 over x minus 2. Those two things are the same. This is just the simplified version of this. And so you can see this is much simpler than this, so why wouldn't we use it? So that's how you simplify. You factor and you cancel. Let's try another example right here. And it's really just that same process every time. You factor and you cancel. All right. So here we go. Right here. X squared plus 11x plus 18 over x squared plus x minus 2. All right, so factor everything, right? You've got to be good at factoring. X and an x looks like a plus 2 and a plus 9 for the top. And on the bottom, you're going to have an x and an x, plus 2 and a minus 1 give us what we need. We notice what the two factors are that are the same, and there we go. So our final answer, our simplified version, is just x plus 9 over x minus 1. Again, that is the same as this, all right, mathematically speaking, but that is a much simplified version. All right, let me show you one that every once in a while you'll run into something like this. Simplify. Let's put an L in there. So let's simplify. You'll run into things like this, and it's not a big deal, but you want to be prepared. 4 minus x squared over 3x squared minus 5x minus 2. All right, so let's start with the process of factoring. So 2 minus x and 2 plus x. And then on the bottom, you're going to have, well, it looks like a 3x and an x, right? And probably a minus 2 and a plus 1. Now, as we look at these things, we don't see anything that's exactly the same, okay? But we might notice that these things, these two factors, are opposites of each other. Notice that the 2 is positive, the 2 is positive, and the 2 is negative. The x is negative and the x is positive. So they're exact opposites of each other. That doesn't mean we can cancel them out right now. But there's a trick that you'll see that you'll do quite often if that's the case, if everything is exactly the opposite. And here's the trick. I'm going to factor a negative out of the 2 minus x. All right? So when I pull a negative out, it becomes a minus 2 and a plus x. It just changes the signs. Everything else stays the same. I've just factored out a negative value. So I'm just writing everything else down. The only thing that changed was this term, right? Everything else is the same, and I just factored the negative out. Notice if you distribute that negative back through, you get back to this right here. So we're still equal. Let me rewrite it one more time. Now that I've factored it out, negative, and I'm just going to swap the order, x minus 2, right? I can just switch those two things around, and 2 plus x, 3x plus 1, and x minus 2. And now look what I can do. Now I've got an x minus 2 and I've got an x minus 2 that are exactly the same that I can cancel out. On the top, I'm still with, that negative still is there, negative 2 plus x, and then on the bottom, 3x plus 1. And we'd probably write that as a negative 2 minus x, distribute that through. But there it is in simplified form.